Welcome back, friends. Okay, so this is our first official session actually. So what we have done in last couple of days were some basics of networking. Okay, so whatever we have seen, we will just try to go a bit deep into all those topics in coming classes. Okay, so this is our first official session and we'll just try to start our syllabus from today. Okay, fine. Now, one of the most important concept we need to learn in computer networks is actually a concept called IP addressing. Okay, so when you go with your networking concepts or server administration, cloud administration, DevOps, cyber security, ethical hacking, anything that is related with our field, IP addressing is one concept that will be with us forever. Okay, so as a network administrator, especially as a network administrator, we should be very much, perfect in this IP addressing concept. So we'll start IP addressing from very basics, from the scratch level. We will start and we will go up to the advanced level. CCNA is actually the only course where we are learning IP addressing in great details. So when you go for a CCNA exam, actually the online examination, probably there will be around 50 to let's say 65 questions in CCNA exam, the online examination. Out of these 50 to 60 questions, actually, at least, 12 to 15 questions will be related to this IP addressing concept. Okay, so this is such an important part of our administration journey, my friend. This is such an important thing. Okay, so every person should know the concept of IP addressing from very basic up to the scratch level. So probably it will take at least 7 classes for us to complete everything in IP addressing. And in case if 7 classes are also not sufficient, I'll go with the 8th class. So I'll make sure you learn IP addressing in the best and the perfect way. Done? Now let us start our session and let us see what exactly is this IP address. Okay, so IP stands for Internet Protocol actually. It is a number that must be assigned on every device because without IP address, communication is not possible. See, when I say device here, I'm talking about the physical device as well as the virtual device. Physical device as well as the virtual. Okay, so whether it is physical or virtual, in physical, whether it is a server, a router, a firewall, a computer, a laptop, okay, a desktop, a mobile phone, any machine, literally every machine will get a IP address. Okay, so every machine will literally get one IP address. Okay, now there are two types of versions we have in IP address actually. One is called IP version 4 and the other one is IP version 6. I repeat, IP version 4 and IP version 6. So when you see the IP version 4, actually, it will look something like this: 192.168.1.10, or it can be 172.16.5.20. It can be 10.1.2.3, something like this. And coming to IP version 6, IP version 6 is actually this number. IP version 6 is pretty big number compared to IP version 4. Okay, but both the numbers are used for communications. Okay, so within our network, there is a local area network, or over the internet, there is a wide area network. Companies can go with IP version 4 as well as IP version 6. Okay, so companies will use both the numbers. But till today, actually, 2025, till today, majority of companies, they will use IP version 4 as their number, at least within the company. Within the local area network, my friend, majority of companies. Okay, if I say majority, I'm talking about nearly 95% companies actually. I'm talking about 95% companies across the globe, or let's say 97 to 98% companies across the globe. Within the local area network, they will use IP version 4 only. Now, over the internet, it is a debatable thing. Over the internet, maybe you're using IP version 4 or maybe you're using IP version 6. But today, suppose you're taking some address from the internet so that you can launch a application server, so that you can launch a web server or something like this. Then in most of the cases, you will be getting some IP version 6 only. Nowadays, it's very rare you get IP version 4 over the internet. But within my company, within my local area network, maybe there are 20 computers, maybe there are 20,000 computers, or let's say 20,000 devices. all the 20,000 devices will get or will have this IP version 4 only. Okay. Now, the question here is, if IP version 4 is available, why they have introduced this IP version 6? You know, IP version 4 was introduced in the year 1980, 1981. So approximately 45 years before the IP version 4 was introduced. And coming to IP version 6, this IP version 6 numbering was introduced in the year 1997, 1998. So again, the question here is, if IP version 4 was already available, what was the reason or what was the need for them to introduce this IP version 6? And the IP version 6 is such a big number, right, compared to IP version 4? Let's see, let's take a very simple example to understand why the IP version 6 came, or why they designed this IP version 6 actually. You know, friends, when we started using mobile phones actually, let's go back to 2005, 2006, around 20 years before, mobile phone numbers used to begin with number 9. Like for example, you know, back in those days, BSNL was using 9440 and then something, 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 something here. Okay. Airtel was using 9498 and then something, something. So literally every company was using mobile phone number with the digit 9. But you know, today, if you go and take a mobile phone number, a new SIM card, a new number, it's very rare that you are getting a number which is starting with digit 9, right? So today you are getting a number that is starting with 8 or 7 or 6. Now the question here is, what is the reason for introducing the number 8 series, 7 series and the 6 series? Why can't they use only 9 series every time? Listen, my friend, if someone is using a number as, let's say 9440, 1, 2, 3, 4, 5, 6. Let's say that is their number. Is it possible for two people to use the same mobile phone number? Obviously, no. So once a person has taken a number, actually, that number is registered for that person on his name or her name, and that person will use that particular number. That number cannot be shared with any other person. The number cannot be shared with any other SIM card or any other mobile phone. Same logic applies here, my friend. You know, in IP version 4, actually, we have some numbers. But you know, whenever a company is using internet, or whenever a company is running some application over the internet, that application needs one public IP address. I repeat, that application needs a public IP address. So once a company takes a public IP address, that IP address is registered for that particular company. Okay. So in IP version 4, we have some limited numbers, and those limited numbers are nearly over. Now there is a big conflict here, right? 10 minutes before I said nearly 90% cases or 95% cases, every company will use IP version 4. But now I am saying IP version 4 are done. There are no free addresses available in IP version 4. So what is the conflict here? See here, my friend. In IP version 4, actually, there are some numbers which comes under public category and there are some numbers which comes under private category. So within our network, within our local area network, we are using a private IP address, which is absolutely free. But over the internet, it is a public IP address. Over the internet, we are using IP version 4. But in IP version 4, which number we are using here, friends? We are using public IP address. So I'm talking about public IP here actually. Public IP addresses are not repeated. Two companies cannot use same public IP address. Two companies cannot use the same public IP addresses for their applications. Okay, so this is the reason the IP version 4 is nearly over the public network. But within the private network, you can use the same number, I can use the same number, my company can use the same number, your company can use the same number. So within the private network, there is no problem. But over the internet, there is a problem here, my friend. So this is the reason over the internet now, literally all the companies started using IP version 6, but within the company, we will still use IP version 4. Okay. Now in CCNA, our major focus is on IP version 4 only. It's not on IP version 6. It is majorly on IP version 4. So the 6 classes, 7 classes or 8 classes, whatever I said, this is only on IP version 4. Okay. Now the question here is, how many addresses are there in IP version 4 actually? Like I said, the IP version 4 addresses are nearly over, right? There are no free numbers available now. But how many numbers are available in IP version 4? Totally, how many IP addresses are available there? Can you say this number actually? 42994 something something. This is more than 4 billion. So in our IP version 4, there are more than 4 billion numbers. To be exact, this is that number actually. This many IP version 4 numbers are available. But you know, my friend, today in the internet times, this number is nothing. 4 billion is nothing, right? Because literally every website over the internet will use a IP address. Every person who is connected to internet will use a IP address. So this is not at all a big number. You know, actually in 1990s, in mid 1990s only, let's say 92, 93, 94, they realized internet was growing very fast and the numbers what we have in this IP version 4 will not be sufficient. So not only today, actually, I'm talking about mid 1990s, 94, 95. These people, they realized IP version 4, we have limited numbers. But you know, in 1981, actually, when they released this IP version 4 or when they designed this IP version 4, they thought more than 4 billion number will be like more than enough for some centuries and centuries to come. Because, you know, in 1981, there was no concept of internet. Computer network was there, but there was no concept of internet. Okay, internet is a public network, right? So the internet concept was not available. Within our company, the private networks were available. So they thought like 4 billion is a very big number. But you know, when internet came, internet became very successful, very famous in early 1990s. And by the time we enter in mid 1990s and late 1990s, Google came, Yahoo came, Amazon was there. So these companies came and the internet was super successful. So this is the reason they designed this IP version 6. Okay. And you know how many addresses are possible in IP version 6? This many numbers are possible in IP version 6. So the total numbers are some trillions and trillions and trillions of numbers. IP version 4 is 4 billion plus. But in IP version 6, we have some trillions and trillions and trillions of numbers. Now we can say the total numbers what we have in IP version 6 will be sufficient for many, centuries to come probably. There is no, reason for them to introduce one more IP version there. Let's say IP version 7 or IP version 8 or something. Because we have sufficient numbers in IP version 6, that will be more than enough. Okay. You need one IP address, I need one IP address, right? Every person, they need one public IP address to communicate with the internet. Suppose imagine, friends, I'm taking some millions of IP addresses. You took some millions of IP addresses. Some other person took some millions of IP addresses. But still, some trillions of IP addresses will be still available in IP version 6. This is such a big number in scheme, my friend. Got it? So these are the two versions we have here, friends, IP version 4 and IP version 6. And both are used for communication. And suppose you're using IP version 4 in your device, and suppose in my device there is IP version 6, still we can communicate with each other. Probably directly we cannot communicate there, but still there are certain ways in which we can make communication there. So this is your IP address, internet protocol that must be assigned on every device, because without the IP address, communication is not possible. So we have IP version 4 number, IP version 6 number. IP version 4 is very old, that is designed in 1981, and IP version 6 is latest one. Compared to IP version 4, it is latest because it is designed in 1998. Okay. So till today, within our local area network, within our company's network, 97 to 98% cases, we are using IP version 4. But over the internet, let us say 70 to 80% we are using IP version 4, and let's say around 20 to 30% we are using IP version 6. But maybe let's say after like 5 years, the IP version 6 percentage will increase. From 20, it may go to 25, 30 or 35. Okay, but still people who are using IP version 4 for last 3 years, 5 years, 10 years or 20 years, they still use their IP version 4 numbers. Done. Now let us just focus more on our IP version 4 design and IP version 4 number. Okay. See here, friends, this is a concept that deals with many numbers. Like there are some numbers called binary numbers. There are some numbers called decimal numbers. There are some hexadecimal numbers, and there is something called octet. So these are the numbers that we need to understand carefully here. And whenever you learn IP addressing, at least from tomorrow, you know what you should do. When you sit in the class, actually, sit with a pen and paper, pen and a book. Because IP address is all about maths here. IP address is all about numbers. So I'll show you some calculations here. You do some calculations there. It will be easy for you to understand the concept of IP address. Okay. Now let us try to understand these numbers: binary numbers, decimal numbers, hexadecimal numbers, and octet. You know what is a binary number, right? Binary number means it is either 0 or 1. Now, where we are using these binary numbers? Are we using these binary numbers in our calculations when we count our money? Are we using the binary numbers? No. Are we using the binary numbers on our vehicle plates, actually, yeah, car number, bike number, and all those things? No, we are not using the binary numbers there. So where exactly these numbers are used actually? Binary number is a concept, or binary number is a number that is used by our machine. It is your machine language. I repeat, binary is our machine language. Whenever you're using something in your computer, whatever you do, my friend, whether you play audio file or you open a video file, you send an email, you play a game, whatever activities you do on your machine, at the end of the day, that particular activity or that particular format will be converted into binary. Got it? You can see there is something written as IP version 4 here. We can see IPv, this is in English alphabets, and 4 is a numeric number. But for a machine, IPv4 is in binary. You can see here there is something called divided written here. Divided is obviously in English. But for a machine, divided is in binary. So the machine language is a binary language. And my friend, the basic of IP address is binary number. If you know the concept of binary number, literally you can understand everything in IP address. Binary number to decimal number. Decimal number to binary number is the most important part of our IP addressing, my friend. Got it? So let us, keep the binary number here. This is 0 and 1. That is your binary concept. Fine. And then we have something called decimal number. Decimal numbers are 0 to 9. The numbers what we use here are decimal number. Your mobile phone number is a decimal number. My mobile phone number is a decimal number. Your date of birth is a decimal number. My date of birth is a decimal number, right? You're counting money. You say $30,000. That is in decimal. I am saying 50 lakh Indian rupees. There is a decimal number. Got it? So decimal numbers are 0 to 9. Now we have two more numbers here actually. Or let's say hexadecimal number. Hexadecimal number is what? Hexadecimal number is a concept where we are using decimal numbers and we are using some alphabets A, B, C, D, E, F. This is your hexadecimal number. So if I say a number like, let's say 73, this is what? Binary. If I say a number like, let's say 73B, this is what? This is a hexadecimal number. Got it? So this is your decimal and this is your hexadecimal. Can I say hexadecimal number is 73, let's say X? No, I cannot say X here. Or let's say W. Can I say W there? No, I cannot say W because in hexadecimal number, we are using only up to F character. Above F, that is not allowed. So this is your hexadecimal format, my friend. Okay. Now see here, friends, when I go and see the IP version 4 here, can you see it is there in decimal? 192.168.1.100 is decimal. But when I see the IP version 6, can you see here 2001, 00001234, and there is something called AB1D, AB23, CC43, 000001, 2C. So what we have here, this is our hexadecimal format. Got it? So IP address can be there in decimal form or IP address can be there in hexadecimal form. So decimal is your IP version 4 and hexadecimal is your IP version 6. Okay, let me just check one number actually. If I go to command prompt here and if I say ping, let's say google.com. See here, my friend, I just said google.com. Now it is showing me some reply. It says a reply from. Can you see this number 240468 something something? Can you see A2B and 200E? This is which number? This is your IP version 6 number. Okay, this is your IP version 6 number. Now, when you see the design here, see in this IP version 6, in my document, there are 1, 2, 3, 4, 5, 6, 7, 8. There are totally 8 groups. But here, how many groups you can see here? 1, 2, 3, 4, 5. There are only 5 groups. So how that is possible? See here, my friend. In this number, can you see there is something called double colon here? Double colon means we are simply skipping some numbers here. So actually the Google IP address is IP version 4 as of now. And this IP version 4 is also having totally how many groups? 8 groups. But here we are using double colon so that, we can make IP version 6 number a bit shorter. Okay, so don't get confused here. Both are IP version 6 numbers only. Let me just check one more connection. Let's say ping facebook.com. Now see here, friends, facebook.com. Number is 2A something, one group, 2, 3, 4, 5, 6, 7, 8. So this is also a hexadecimal number. Got it? So we have hexadecimal number in IP version 6. Okay, so I hope it is clear now, the decimal, binary, and hexadecimal numbers. And then there is something called octet. What is octet or what is octa? Normally you see your mobile phone is octa-core processor. Your laptop is having a octa-core processor. What is the meaning of octa-core here? Octa-core means a processor with totally 8 cores. Okay, means this is one processor and this one processor is divided actually into totally 8 portions. So octa means how many? Octa means 8. So what is the octet here? Octet is collection of 8 bits is the octet. Now where we are using octet that we will see, but as of now, this is also one number that we need to see. Okay, so I hope it is clear. Binary numbers, decimal numbers, hexadecimal numbers, and octet. To understand the concept of IP addressing, my friend, you should be very good in these numbers. So we will try to see many things in these numbers. We'll try to take many examples and we'll try to understand these numbers in the perfect way. Okay, so just understand the numbers. Your IP version 4 concept will be very clear. And if you're good in this IP version 4 concept, or if you're good in the IP addressing concept, you will be very good actually in cyber security, cloud computing, CCNA, Linux server administration, DevOps, and all the other technologies. This is one of the topic where people are lacking good knowledge. They are not comfortable in this concept because you are not learning it properly. They feel like, okay, within half an hour, I can get some concept of IP addressing. That's enough. Within 1 hour or within 2 classes, they can learn IP addressing. That's literally not possible, my friend. You need to spend some time here, at least 1 week, at least 6 to 7 classes you need to spend so that, for rest of your life, for rest of your career, there is no need for us to again, revisit or repeat the concept of IP version 4. That much we need to learn. Concept will not change. IP version 4 or IP version 6, concept will not change. Okay, so we need to understand it once. We need to learn it once and learn it perfectly. Done? Now, the rules are same actually. Let me just, remind you again, there is a chat box here. So whenever you have any doubt, feel free to send your question in chat box so that, I can come to your question at the earliest. Keep your chat box busy every day, friends. Your questions will make sessions more interesting. If the sessions are interactive, the sessions will be very interesting, my friend. Okay, so do not take your question back home. Just clear every doubt. This is the best advantage you can take in an online session. You have the option of option to interact with the trainer. Done? Fine. Now let us move into IP version 4 in more details. Okay. Now see here, friends, when these people were designing IP version 4, they design IP version 4 by taking actually 32 binary bits. So normally we say IP version 4 is a 32-bit binary number and IP version 6 is 128 binary number. You know what is the meaning of binary now? 0 or 1 is binary, right? 0 or 1 is binary. Okay, so IP version 4 is 32-bit binary numbers. So these are your 32 bits actually. These are your 32-bit binary numbers. But does it make any sense if you just take all 32 binary numbers 0, 1, 1, 0, something like this? No. You know, the design of IP version 4 is there are 32 bits available, but these 32 bits are divided actually into totally 4 octet. Now, see what is the octet here? Octet is collection of 8 bits. So IP version 4 design is having 32 bits, but 32 bits are divided into 4 octet. Each octet contains how many bits? 8 bits, 8 bits, 8 bits, 8 bits. So how many total? Total 32. And each octet is separated by a dot. So this is your first octet, this is your second octet, this is your third octet, and this is your fourth octet. This is the design of IP version 4. Okay, you can see here the number is 172.16.50.2. 172 is there in the first octet, 16 is there in the second octet, 50 is there in the third octet, and 2 is there in the fourth octet. So these are totally 4 octets. Okay, so this is the design of your IP version 4. There are totally 32 bits, and 32 bits are divided into 4 octets, and each octet is separated by a dot. Now see here, friends. There are two addresses here. One is 172.16.50.2, and the other one is 172.16.350.2. You know, out of these two addresses, actually, one address is correct and one address is incorrect. So the question here is which number is correct and which number is incorrect. 172.16.50.2 is correct, or 172.16.350.2 is correct actually. You should answer this question actually. I'll just go with this session. I'll just try to explain few more things here. So you should tell me out of these two numbers, which number is correct and which number is incorrect. Okay. Okay, I already got an answer here, but let us wait, Raja. Let us wait for like few more minutes and let us see which number is correct and which number is incorrect there. Okay. Now see here, friends, there is a very big note here. What it says, IP version 4 is a 32-bit binary number. But see, 172.16.50.2, is it a binary number here, friends? No, this is a decimal number, right? So see here, friends, IP version 4 is a 32-bit binary number, but for a user, IP address is in decimal. I repeat, for a user, IP version 4 is in decimal format. Okay, means if I go to my computer actually, and if I try to assign the IP address here, let's say this is my computer. I'm trying to assign the IP address in my computer here. So I can see IP version 4 here. Go to properties and say use the following address. Can I use binary numbers here? 010101? No. Can I say 192.168.10.25? This is accepting here, right? But you know, when we started our session, what we said, remember? We said IP address is in binary language. 192, is it binary? No. 168, is it binary? 10, is it binary? No. No octet is in binary. So what is the concept here? For a computer, for a machine, everything is binary. But for a user, it is presented in some other form. IP address is in binary, but it is presented in decimal form because we are more comfortable in decimals. 192.168.10.25, we are more comfortable in this number. We are used to the decimal number, so they are presenting this in the decimal form. But actually, in the background, once you say 192, you know what machine will do? Machine will convert 192 into binary. Machine will convert 168 into binary. Machine will convert 10.25 into binary. So literally, at the end of the day, it is in binary. But for a user, it is in decimal form. But you know, friends, we are not normal users here, right? We are administrators. We are server administrators. We are network administrators. We are cloud administrators, DevOps administrators, cyber security administrators. We can be any of these things, right? So we are not so common people. We are, you know, very, technical people in a way, right? So if you know 192.168.10.25 is an IP address, that's not a big deal for us. It's a big deal maybe for a non-technical person, but for us, we should know what is 192 in binary, what is 168 in binary, what is 10 in binary, what is 25 in binary. how exactly the numbers are converting, how the machine is able to understand the IP address. We need to learn all these things. Got it? Just taking the number and assigning the number is not a big deal, my friend. Understanding what is happening in the background, understanding what is happening in the back end of your IP addressing, that is the major thing. Okay, so let us try to understand what is happening there. See, to understand what exactly is happening there, you know what we have to do, friends? We just need to learn this thing, binary to decimal conversion. Now I'm taking you back to the primary school, right? Somewhere in 4th class or 5th class, you might have learned this binary to decimal conversion, decimal to binary conversion. If you still remember, great. If not, you have to brush up your skills again. You have to simply revisit binary and decimal conversions. If you know binary decimal conversion, my friend, you can learn IP addressing perfectly. Got it? So let me just go through the binary decimal numbers from basic to the advanced level. See here, friends, these are totally 32 bits here, right? There are totally how many bits? There are totally 32 bits. But 32 bits are divided into how many octets? 4 octets. So this is octet number 1 here. This is octet number 2 here. This is octet number 3. And this is octet number 4. Right? There are totally 4 octets. So starting from your left side, so the blue color octet is 1, the green is 2, yellow is 3, and the last one is your 4th octet. Okay. So we just need to see how we can convert these binary numbers into decimal numbers. It's very easy, my friend. Let me just take you. Okay, I'll just show you some examples here. Let us see. Now see here, friends. I'm converting a binary number into decimal number. So what binary number I need to convert here? Can I convert binary number as 1, 1, 0 into decimal? I can convert. It is not 110. This number is not 110. This is 110. Okay, so this is not 110. This is 110. 110 in binary. So this 110 we need to convert into decimal. For example, we have, let us say 110, 0, okay, 0, 0, 1, 1. This is not 1,10,011. This is not the decimal number. This is your binary number, 110011. So you can take 110 binary number, you can convert into decimal. You can take 110011, the binary number, you can convert into decimal. But you know what we do here, friends? We are not taking 3 bits or we are not taking 6 bits. We will take totally 8 bits. What I'm trying to say here is you can convert any number of binary numbers into decimal. You can even take, 70 binary bits, 1001, 10111, something like this. You can take 70 binary bits in a sequence and you can convert them into decimal. That is possible. But why we are simply taking only 8 bits here? The reason is quite obvious, right? See here. IP version 4 is IP version 4 is totally 32 bits. These 32 bits are divided into 4 octet and each octet contains 8 bits. This is the reason, my friend, I'm taking 8 binary bits and I'm converting these 8 binary bits into decimal. Done? Now let's see how to do this. Suppose I will take the number as the binary number as, let's say 1, 1, 1, some combination here. Randomly, I'm just taking some combination here. That's it. This is my binary number. So what will be the decimal number of this combination? How to calculate the decimal number of this calculation? Very simple, my friend. When you do the calculation, this bit is counted as first bit. This is counted as second bit, third, fourth, fifth, sixth, seventh, eighth. There are totally 8 bits, right? My friend, whenever you do the conversion from binary to decimal, we need to follow a particular formula. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. This is the formula we need to follow. Base is 2. Why we are taking base as 2? Why not 10 power 0, 10 power 1, 10 power 2? We are taking base as 2 here because this 2 is your binary number, total binary numbers, right? 0 and 1, so it is 2. Now tell me, what is 2 power 0? Anything to the power of 0 is what? 1, right? 2 power 1, 2. 2 power 2, 4. 2 power 3, 8. 2 power 4, 16. 2 power 5, 32. 2 power 6, 64. 2 power 7, 128. We are just doubling the numbers here, right? So these are the bit values. These are the binary bit values. Now let's see if there is one more bit available. It will be how much? It will be 2 power 8. So 2 power 8 is how much? 256. Let's say there is one more bit available. 2.9. 2.9 is how much? 512. So this will not end actually. This will keep going. But you know why I'm stopping at the 8th bit here? Because there is a reason. The IP version 4 is 32 bits. 32 bits are divided into 4 octets. Each octet contains 8 bits. So we need to stop at 8th bit only. Got it, dear friends? Every bit has a bit value. The first bit value is 1, second bit value is 2, then 4, then 8, then 16, then 32, then 64, and 128. This is not only in the first octet, and the second octet also same. See here, if you go with the second octet here, what is the bit value of this particular bit in the second octet? It is 2. What is the bit value here? 2. What is this bit value here? 2. What is the bit value of this bit here? 32. This bit value? 32. In the third octet, 32. In the fourth octet, 32. The bit is 0 or 1. It doesn't matter what is the bit value. It can be 0 or 1. The bit can be 0 or 1. But what is the bit value here? It will be 32. So we just need to see every bit value. Okay. Just write down all these things on paper. It will be super easy for you to remember. Now, what is the next thing we have to do here is we just need to see where the bits are zeros and where the bits are ones. So see here, friends, here the bit is 0 and 1. Means wherever the bit is 0, actually, that particular bit is off. And wherever the bit is 1, that particular bit is on. That is the simplest calculation we have to see here, friends. Just need to see where the bits are zeros. 0 means off. Ignore it. 1 means on. So see in this example, how many bits are on here actually? In this example, this bit is on, this bit is on, this bit is on, this bit is on, this bit is on. And remaining these 3 bits are off. So just forget about these bits that are off. Just try to see the bits that are in on position, that are in ones. Ones means they are in on. Now you know what we have to do, friends. What is this bit value here? 128. What is this bit value here? 64. What is this bit value here? 32. What is this bit value here? 2. And this one is 1. So I'm just trying to count the bit values here. So now I need to say 128 plus 64 plus 32 plus 2 plus 1. So 128 plus 64 is 192 actually. 192 plus 32 will be 224. 224 plus 2 will be 226 and 226 plus 1 will be 227. So this binary combination is 227. 111000011. This is a binary number, and in decimal, what it will come? It will come as 227. Clear? Let's go with few more examples here, friends. Okay, so let us say 1, 0. I'm just randomly selecting some numbers here, my friend. This is some binary numbers. What I have to do now? I just need to convert this binary number into decimal. So what I have to do? Where are zeros and where are ones? Where are ones here? Just see those numbers here. So the ones are here, right? 128, 16, 4, 1. So 128 plus 16, how much? 128 plus 16 is, I guess, 144, right? 144 plus 4, 148. 148 plus 1, 149. 149. This is your 149. Clear? Just see where are ones. See the bit values. Add them, you'll get your decimal value. See, there is a very big reason, my friend, why we are learning this binary decimal conversion actually. And decimal to binary also we need to say, this is the foundation of your IP addressing. IP addressing the foundation of complete network. Okay, so this is not a very small thing. If you know also, better try to do more practice so that you know orally you should do the conversion, not on paper. Just see the binary number. Okay, this is a binary number. This will be the decimal number. That much perfection you should get here, my friend. Okay. Now let us see few more examples here. What I have already written here. See, in this example, 128 plus 64 plus 32 plus 2 is how much? 226. 128 plus 32 plus nothing else, right? So 128 plus 32, how much? 160. Here, 128 plus 64 plus 32 plus 16 plus 4 plus 1. How much? 245. Here, 128 plus 64. Nothing else. So it is how much? 192. These are your binary to decimal conversions. Okay. Now there is a small challenge for you, friend. There is a small thing that you have to do. Give me a second, please. Okay, so can you see these numbers here? There are totally how many? 1, 2, 4, 6 combinations, right? 6 binary numbers. You have next 2 minutes. Let us say 120 to 150 seconds are there for you, my friend. Can you please convert these numbers into binary? Sorry, can you keep convert these binary numbers into decimal? Okay, take your time. You have couple of minutes. Just try to convert these binary numbers into decimal. Keep answers with you. After a couple of minutes, we will see our answers. We'll verify like whether our answers are matching or not. Okay. And after converting, actually, you will get a very important point about this IP version 4. Okay, so good luck. You have like next couple of minutes. Okay, I hope you're ready with your answers. These are like very easy conversions actually. So there are totally 6 binary numbers we have. So just try to convert them into decimal. Okay, let's take another 30 seconds and let's see our answers. Okay, can I get answers from your side, please? Can you just share your answers in chat box? Yeah, Satya, Raja, exactly 15. I'm just expecting few more answers and I'll share the answers to you. Yeah, Satya, you got all the answers correct actually. Exactly. Fine. Okay, so I'll share the screen now. See your friends. These are your answers, right? 15, 240, 170, 85, 0, and 55, 255. Right? These are the conversions, binary to decimal conversions. Okay, so before I proceed, before I see why we have learned this conversion, let me just, announce one thing again. Tomorrow, that is 38th January, morning 6 a.m., right? 6 a.m. Just write down the time here. 6 a.m. We are starting our Linux administration, right? So people who are interested in this package, I think if you are coming for CCNA, you should come for the complete package. Okay. In case if you have already done the Linux administration, you're working on Linux, that's a different case. If you're not aware of the Linux administration, my friend, this is a package for you. Evening 9 p.m. is CCNA and morning 6 a.m. you have Linux server administration. So tomorrow, please do join the session in case if you're coming for package, because this is the best way you can complete this complete package in next, let's say 40 days or 45 days. Okay. So in case if you have not yet received the uh, link, then please ping me on my number here. I'm just sharing the number. This is my WhatsApp number. Just ping me on my WhatsApp number. I'll share you the link. So tomorrow and after tomorrow, we have like a couple of demo sessions. So there we will see what is Linux and what are the other things that are related with Linux and everything. Okay, fine. So let's come back to our scenario. The binary decimal conversion. So why we have seen this binary decimal conversion? There is a big reason here. 6 a.m. IST Abdul Rahman. Yes, 6 a.m. Indian Standard Time. Okay, so see here, friends. See, in case if you're not comfortable in 6 a.m. due to some reason, maybe if you're in some other country, then we'll start one more batch within few days, or let's say within like 10 days or 2 weeks actually, at some other time, maybe in evening. But in case if you're comfortable with 6 a.m., then there is no issue for you. You can easily join it morning 6 a.m. Okay, so see here, friends, when you convert these binary numbers into decimal numbers, like I said you, there is a very big lesson here. There is a very big thing we are learning about IP version 4. See, here, all these bits are in zeros. Then decimal is how much? 0. Here, all the bits are in ones. And the decimal is how much? 255. So the bottom line here is your IP version 4 is having 4 octets, right? There are 4 octets. So when you talk in the decimal language here, my friend, every octet has a range that is starting from 0 and ending at 255. 0 to 255, 0 to 255, 0 to 255. This is the IP version 4 range. The numbers are there between 0 and 255. We simply cannot use a number like 256 or above 256. This is the limit of IP version 4. Every octet we can use a decimal value between 0 and 255. The reason is if you use any number from 0 till 255, the binary will be totally 8 bits. It can be any combination. Like for 240, it is 111100000. For 160, it is, 1010000, something like this. So it can be any combination. But the thing here is if you take any number from 0 till 255, how many binary bits will be there? 1, 2, 3, 4, 5, 6, 7, 8. 8 binary bits will be there for sure. So this is the range of your IP version 4, 0 till 255. Total numbers are 256 because 0 is counted as a number. See here, the IP address here is 192.168.0.1 and the IP address here is 192.168.0.286. So why this number is correct and why this number is incorrect actually? See the fourth octet here, it is 286. Can you use 286? No, my number should be between 0 and 255 only. I simply cannot exceed my limit. If I go beyond 255, the IP address will not be accepted. Okay. Listen carefully, friends. There is a very, simple point here. The range is between 0 to 255. So total numbers are how many? Total numbers are 256. That means 0 is counted as a number. So 0, 1, 2, 3, 4 up to 255 means how many numbers? 256 numbers. But can I use an IP address like this? Let's say 256. Is it allowed? No, 256 number is not allowed. I cannot enter the number as 256. It is not allowed. So the numbers are between 0 and 255 only. Now let's see one calculation here. If I go to my calculator and if I say 2 power 32. Why 2 power 32? Because there are totally 32 bits, right, in IP version 4. What is the number? Can you see this number? 4294967296. If I say 256 multiplied by 256 multiplied by 256 multiplied by 256. How many 256? 4 256. What is the number here? 409496 something something something. So whatever way you do the calculation, my friend, if it is 2 power 32, you have this many IP addresses. If you just multiply 256 4 times, then you have the same number of same output there, right? So IP version 4 is 32-bit, and in this 32-bit, we have totally this many addresses. Okay, there is a total number of addresses. But what is the design of IP version 4 here, my friend? The design of IP version 4 is 32 bits are divided into 4 octet, and each octet is separated by a dot. So when you convert one octet into decimal, all the 8 bits into decimal, the least decimal number we get is the 0. The smallest one is the 0. And the biggest decimal number is 255. So the IP addresses are between 0 and 255 only. IP version 4 addresses are between 0 and 255. I repeat, IP version 4 addresses are between 0 and 255. Got it? Now, before we end the class for today, let me just show you the IP address concept again, the practicals of IP address, how we can assign the IP address in a Windows machine. How to assign IP address in a Cisco router will be different. How to assign IP address in a Cisco switch will be different. How to assign IP address in a Linux operating system will be different. But in all these machines, Windows machine, Linux machine, Cisco router, Cisco switch, can I say 192.168.1.10? Of course, I can say the same number in any of the device. So see, I just said 192.168.1.10, so there is no problem here. But now, if I say 192.168 dot, let us say 282. Now, see here, my friend, there is an error here, right? What it says, 286 is not a valid entry. Please specify a value between 0 and 255. Clear message, right? It says use a value between 0 and 255 only. You cannot exceed beyond 255. That's the limit. That is the limit of IP version 4. Not only in the third octet, in any octet, we cannot use 258 or we cannot use above 255, any octet. Okay, so the number is 192.168 dot. Let us say 10 dot. I'll go with, let's say, 0.1. So 0 is also accepted here, right? So 0 is also accepted as a number. So this is your IP version 4, my friend. Okay, so this is something about IP version 4. This is just the beginning here, my friend. You know, we have to go a bit long way actually to learn IP addressing. CCNA is the only course where you will learn IP addressing in so much details actually, my friend. Okay, so at least from tomorrow when you come in the CCNA class, come with a book and a pen so that, you know, you can do practicals quickly there. And, you know, you can interact with me through the chat box and you can share your answers. I can share my answers. We'll just try to keep these sessions more interactive actually, right? So that, you know, you can learn concept in much better way. Okay, so as of now, this much is enough for the day and the IP version 4 concepts. I'm here for like 30 more seconds, friends. If you still have any doubts, feel free to send your questions in the chat box. And if you want to talk to me directly, it's up to you. You can unmute yourself and you can talk to me. And the second thing is, like I said, this is our first official class. Yesterday and before yesterday, what we have done is only the demo. We have just tried to understand like what is networking and what we can do in this networking. So if anyone has missed those classes, the classes will be available on YouTube. But today's session, which is already recorded, actually recording is on here. So today's session and from today, all the sessions will be shared with people who have registered for this particular course. Okay, so they will share these classes only with people who have registered for this particular course. So how you can register for this particular course here or for this particular package? These are the numbers. You should contact on these numbers, friends. And you know, whatever is the process, just follow this process. So from today, they will not share the recordings with everyone. That is one thing. And most probably tomorrow, I think they will change the link. So in case if you want to continue with these classes, this is just a reminder from my side, my friend. So I just need to, you know, inform you this. So in case if you want to continue from tomorrow, then, you know, my friend, you have to take a link from the management. Got it? So this is something that I need to inform you. So this is the thing you should take from the management. And tomorrow 6 a.m. RHEL, Red Hat Enterprise Linux 9.x version, the latest version we are going to start tomorrow exactly at 6 a.m. So this is a package. So next, let's say 40 days. You can done with your CCNA part, Linux administration part, as well as I'll share some of the previous Windows Server administration recorded sessions. You can do everything in next 40 to 50 days. Okay. Then you can apply for jobs. You can, you know, search for your jobs and all those things. Or else in case if someone is interested to go with like higher courses or the new technologies like cloud computing or DevOps or cyber security and all those things, you will be 100% ready for those courses, my friend. To learn cloud computing or cyber security or any of those things, you should be very good in networking part, that is especially CCNA part and this server administration part. This is one mistake literally every person do, or let's say at least, you know, out of 10, at least 8 people do the same mistake. They just try to go and learn cyber security on day one. You know, when you see a movie, in movie they will show you a hacker, a very, you know, hi-fi hacker will be there. He is hacking or she is hacking something within some 30 seconds. No, my friend, those technologies are not so easy. Those technologies will become easy when you go with the foundation, when you start your career from the foundation. Okay, fine. So this is something that I need to inform you. I'm here for you for next 30 seconds. Any questions we will see, or else we can stop the session for today. And please join the sessions tomorrow regularly at 9 p.m. because we need to take at least 60 minutes every day. So 9 to 10 p.m. will be the perfect time for us. Okay, fine. So I guess there are no questions here, friends. We can stop the session here today and hope to see you again tomorrow with a new link in the CCNA. And in case if you're interested for this complete package, see you tomorrow 6 a.m. And if you want to get the link of the 6 a.m., either contact the management on the numbers that I have given there, or you can simply ping me on my number, what I have entered in the chat box. So you can ping there. I can share the link and you can simply attend the demo, at least the demo session for tomorrow. Okay. Thanks a lot, friends. Take care. See you tomorrow.